In this video, we're going to talk about another type of improper integral. We're going to talk about a type 2 discontinuous integrand integral. So if f of x is continuous on the interval ab and is discontinuous at x equals b, then the integral from a to b f of x dx is equal to limit as t approaches b from negative side integral a to t f of x dx. Now a key concept here, the discontinuity is at b, at this upper limit. So we replace the upper limit by t and take the limit as t approaches b from the negative side. So let's look at an example. Integral from 0 to 1, 1 over x minus 1 dx. We can rewrite this as limit t approaches 1 from the negative side, integral from 0 to t, 1 over x minus 1 dx. And the area that we find corresponds to this shaded area right here. All right, if another type of definition, if f of x is continuous on the interval ab and is discontinuous at x equals a at the left endpoint, then the integral from a to b f of x dx is equal to limit t approaches a from the plus side, integral from t to b, f of x dx. Notice in this case the discontinuity is at the lower limit at x equals a, and that lower limit gets replaced by t, then we take the limit as t approaches a from the positive side. As an example, integral from 0 to 1, 1 over x squared dx, that's going to be equal to limit t approaches 0 from the plus side, integral from t to 1, 1 over x squared dx. So going over this example again, integral 0 to 1, 1 over x squared dx. This is a limit t approaches 0 from plus side, integral from t to 1, 1 over x squared dx. That is this area here. The integral, the improper integral, corresponds to the shaded area that you see here from 0 to 1. These improper integrals a to b f of x dx, they converge if the limit exists and is finite, and diverges if the limit doesn't exist. If f of x has a discontinuity at x equals c, where c is somewhere in between a and b, then we can split up the integral a to b f of x dx into the sum of two separate integrals. So we rewrite this as integral from a to c f of x dx plus integral from c to b f of x dx. Now let's write it in the formal improper integral notation. We write this as limit t approaches c from negative side, integral from a to t f of x dx plus limit as t approaches c from the plus side, integral from t to b f of x dx. So essentially you're splitting up this interval from a to b, you're splitting it up from a to c, and then from c to b. And so by doing that, of course, at x equals c, this is where your discontinuity is, you're splitting it up into two separate integrals. A to c f of x dx plus integral from c to b f of x dx. All right, so here's an example. The first integral, a to c f of x dx, corresponds to this area here, this area that's shaded. The second integral on the right corresponds to this area here, this shaded area. If both of these integrals converge, then the whole integral, integral a to b f of x dx, converges. But if one of these integrals diverges, then the whole integral, it also diverges. So let's look at an example. Here we have integral from 0 to 2, 1 over x minus 1 squared dx. We can split this up, integral from 0 to 1, 1 over x minus 1 squared dx, plus integral 1 to 2, 1 over x minus 1 squared dx. Now here's a question. Why do we split it up at 1? What's the reason behind that? The reason is because the integrand blows up at x equals 1. Because you get 1 over 0, and 1 over 0 goes to infinity. The y value goes to infinity. In formal notation, we write this as limit t approaches 1 from negative side, integral from 0 to t, 1 over x minus 1 squared dx, plus limit t approaches 1 from the plus side, integral from t to 2, 1 over x minus 1 squared dx. So again, replace this discontinuity, which is 1, by t, and then take the limit as t approaches 1 from the minus side. Replace the lower limit in the second integral, the discontinuity at x equals 1, replace that by t, and take the limit as t approaches 1 from the plus side. All right, let's look at an example. Here we have integral from 2 to 3, 1 over root 3 minus x dx. So you can see that this is an improper integral. Why is that? It's because at x equals 3, the integrand blows up. 1 over root 3 minus x goes to infinity. That's the reason it's an improper integral. So this is a type 2 improper integral. Since the integrand, 1 over root 3 minus x, is not continuous at x equals 3, we have a vertical asymptote at x equals 3. Since the discontinuity is at the right endpoint, we write integral from 2 to 3, 1 over root 3 minus x dx is equal to limit t approaches 3 from the minus side, integral from 2 to t, 1 over root 3 minus x dx. This is equal to limit t approaches 3 from the minus side, integral from 2 to t. Let's rewrite the integrand as 3 minus x to the power of negative 1/2 dx. So we get limit t approaches 3 from the minus side. We're going to integrate this. We're going to basically reverse the power rule. There's also a U substitution. We're letting u be equal to 3 minus x, and du is equal to minus dx. So integrating, we get 3 minus x to the power of negative 1/2 plus 1 gives us 1/2. Divide by 1/2, and also divide by negative 1. Why do we divide by negative 1? Is because of the chain rule or U substitution, du is minus dx. And evaluate it from 2 to t, we get limit t approaches 3 from minus side. Simplifying, we get minus 2 times 3 minus x to the power of 1/2, evaluated from 2 to t. So now let's put the upper and lower limit in. Let's apply the fundamental theorem of calculus. Minus 2 times 3 minus t to the 1/2 minus 2 times 3 minus 2 to the power of 1/2. And don't forget to put a limit. Limit t approaches 3 from minus side. So what do we get? We get minus 2 times 3 minus 3 from negative side to the power of 1/2 minus 2, that's plus 2 times 3 minus 2 is 1. 1 to any power is just 1. That gives us minus 2 times 0 plus, that means a small positive number, to the power of 1/2 plus 2. Well, root of 0 is just going to be 0. So we get 0 plus 2. The answer is 2. That means the improper integral converges, and the answer is 2. All right, let's look at another example. Here we have integral from 0 to 1, 2 minus 3x dx. Why is this an improper integral? So this is a type 2 improper integral because the y value, since y is equal to 1 over 2 minus 3x, has a vertical asymptote at x equals 2/3. Because if you make the denominator 0, 2 minus 3x is equal to 0, and solve for x, 2 is equal to 3x, divide by 3 both sides, you'll get x equals 2/3. That's the point of discontinuity. That's what makes this an improper integral, because at x equals 2/3, 1 over 2 minus 3x, the integrand, goes off to infinity. It blows up to infinity, and we have an improper integral at x equals 2/3. That's what causes it. So what we're going to do is we're going to write this integral from 0 to 1, 2 minus 3x dx, into the sum of two separate improper integrals. So we'll write this as integral from 0 to 2/3, 1 over 2 minus 3x dx, plus integral from 2/3 to 1 over 2 minus 3x dx. Now I want to emphasize this. Why is it that we're splitting it at x equals 2/3? The reason is because at x equals 2/3, the integrand goes to infinity. That is the reason. So we write this formally. This is limit t approaches 2/3 from the negative side, integral from 0 to t, 1 over 2 minus 3x dx, plus limit t approaches 2/3 from the plus side, integral from t to 1 over 2 minus 3x dx. Now let's consider the first integral, limit t approaches 2/3 from minus side, integral from 0 to t, 1 over 2 minus 3x dx. So we have limit t approaches 2/3 from negative side, integral from 0 to t, 1 over 2 minus 3x dx. That gives us limit t approaches 2/3 from minus side. And what is the antiderivative of 1 over 2 minus 3x? That's going to be log of 2 minus 3x divided by -3 because of the U substitution. Integrate from 0 to t. Now let me be more clear about that. We're letting u be equal to 2 minus 3x. We're differentiating both sides. We get du is equal to, derivative of 2 is 0. We get -3 dx. If you solve for dx, you'll get du divided by -3. That's the reason we're dividing by -3. All right, so we get limit t approaches 2/3 from minus side of log of 2 minus 3x evaluated from 0 to t. That gives us, let's apply the fundamental theorem of calculus. We get limit t approaches 2/3 from minus side log of 2 minus 3t minus log of 2, because we're plugging x equals 0 here, and we just get log of 2. All right, if we take the limit as t approaches 2/3 from minus side, it's clear that we're going to get log of 0 plus, a small positive number close to 0, minus log 2, and this is all divided by -3. So I just need to correct myself here. Let's divide all of this by -3, and divide all of this by -3, and divide all of this by -3. In any case, log of 0 is going to go to minus infinity. So we get minus infinity divided by -3. The answer is going to be infinity. That means the integral converges. Now, we only looked at the first integral. If you go back to the previous page, we had two separate integrals. Integral from 0 to 2/3, 1 over 2 minus 3x dx, plus integral from 2/3 to 1 over 2 minus 3x dx. But this integral diverges. We show that this is infinity. We don't even need to compute the second integral. We don't need to compute this one. If one of them diverges, the whole thing diverges. Let's talk about that more. So since the first integral, 0 to 2/3, 1 over 2 minus 3x dx diverges, it's infinity, we don't need to evaluate the second integral. Integral from 2/3 to 1 over 2 minus 3x dx, and we conclude that the whole integral, the integral from 0 to 1 over 2 minus 3x dx, diverges. All right, let's do a bit of review, the drawings that we had to do here. So here we have integral from 2 to 3, 1 over 3 minus x dx. This was exercise 1, and we showed that this integral converges and has a value of 2. And that means that this area, this shaded area, is 2. Let's do a bit of integration review. So integral 1 over ax plus b dx, this is going to be log of absolute value of ax plus b divided by a plus c. We're doing U substitution. We're letting u be equal to ax plus b. It differentiate both sides, we get du is equal to a dx. If you solve for dx, you get du over a. The reason you divide by a here is because of this a here. All right, in the second example, we had integral from 0 to 1, 1 over 2 minus 3x dx, and you may recall we split that up as integral from 0 to 2/3, 1 over 2 minus 3x dx, plus integral from 2/3 to 1 over 2 minus 3x dx. We found that the first integral diverges and has value of infinity, so the whole thing diverges. Let's do a bit of the U substitution review of 1 over root ax plus b. This is the integral ax plus b to the power of negative 1/2 dx. We reverse the power rule and apply the U substitution as well. We get ax plus b. And we add 1 to the exponent. Negative 1/2 plus 1 is 1/2. Divide by 1/2. But we also divide by a. That's very important. That's because of U substitution. Plus c. So what we're really doing is we're letting u be equal to ax plus b. We differentiate both sides. We get du is equal to a dx. We solve for dx. We get dx is 1 over a du. The reason you divide by a here is exactly the reason that we divide by a here, is U substitution. All right, thank you.